Hello everyone. So today is day 27 of the challenge. Let's go to the problem from the list, and the problem is that we have to build a simple transformer based model called BERT for text classification. And we are going to use IMDb Dataset. Let's use the same context window here as we have been using for all our previous problems. So I'll say, hey, it is day 27 and here is the problem statement. So let's wait for it to generate the response, and if required, I guess it will be required to understand what BERT is. We'll ask for that as well. Okay, okay, this looks solid. And tomorrow we'll be fine tuning on common and NLP tasks, so it looks solid. So it says this is an exciting task. Today we will work on building a simple transformer based model using BERT, which is bidirectional encoder representations from. I'm really sorry, just wait a second. We'll use BERT, which is bidirectional encoder representation for transformer for text classification. Specifically, we will use IMDb Dataset to classify movie reviews as positive and negatives. We have used this dataset before also for our problems. So understanding and exploring this dataset won't be a problem or won't be a new thing. But before I proceed, I want to understand this. Can you explain in easy what is and what are transformer based models and how are they different from sequential model? So let's wait for it to generate. My cat is getting scared, so I'm going to pause the video for now. So sorry, my cat was scared, so I had to put him in his house. So yes, it has generated the response. Let's understand what BERT is before we start coding. So BERT stands for bidirectional encoder representations from transformers. It is a transformer based model, okay, developed by Google, okay, that is specifically designed to understand the context and meaning of words in a sentence. So it is designed to understand the context and meaning of words in a sentence, okay. Imagine you have a book and you are reading a sentence. Okay. To understand a word in that sentence, you usually look at the words before and after it. For example, in a sentence, the bank is full of fish. The word bank does not mean a place where you store money. It means the river bank. But works similarly. It reads the entire sentence from both the sides, which is why it is called bidirectional. Okay, so it tries to get the context from the sentence of word from the sentence, and it does that from both the side to get the better understanding. Now, BERT is a pre-trained model, which means it has already been trained on a huge amount of text. If you remember, we have worked on a problem where we have used a pre-trained large model. So BERT is also a pre-trained model, which means it has already been trained on a huge amount of text like Wikipedia, and understands a lot about language. We can then fine tune BERT for our specific tasks like classifying movie reviews or translating text. Okay, okay, makes sense. So it is a pre-trained model already trained on a huge amount of text. We are going to fine tune it based on our specific needs. So what are transformer based models? Transformer based models like BERT are a type of natural network architecture that has become very popular for natural language processing. Tasks such as language translation, text classification, and text generation. First, for tasks related to text, these are the transformer based models. Um, so Transformer were introduced to solve some of the major issues that older models had, especially when it comes to understanding long sentences and or dealing with the context. Yes, so in terms of understanding long sentences or dealing with the context, understanding the context, transformer were introduced. Okay, so and this is where the old models were lagging. So, unlike the previous models that read the text word by word in a sequence, Transformer use something called self attention. Okay, this allows them to look at all the words in a sentence at the same time and understand how each word relates to every other word. Okay, this makes them very efficient at understanding the meaning and context of the words even in long sentences. So it is really good and helpful for. Just a second, let the airplane noise go. Okay, so yeah, what it says that uh, it is really good at understanding the meaning and the context of the words. Why? Because of this self attention technique that it uses, and it uses to look at all the words in a sentence at the same time and understand how each word relates to every other word. Okay. So how are these transformer models different from sequential model? So sequential models are often simpler neural networks architecture, okay, that process information step by step in a sequence. A popular type of sequential model is recurrent neural network or long short term memory. We have explored them, which reads data in a sequence like reading a book word by word from start to finish. This is good for small sentences, this is for larger sentences because it has a memory bus type thing that we have already explored. Here's how transformers are different. Here's how transformers are different from sequential models like RNNs or LSTMs. So, in terms of parallel processing, in sequential models, the models read one word at a time in a sequence. This makes it slower, especially for long sentences, because each word depends on the word that comes before it. In transformers like BERT, you don't need to read word by word in order. They look at all the words at once using self attention that we just saw, which makes them faster and able to understand long range relationships between words. Okay, so it is reading all the words word by all at once using self attestation, which is why it is faster. In sequential model, it is doing word by word, so that is why it is a little slower. Now, better context understanding. In sequential models, it is difficult for the model to remember the beginning of a long sentence when it gets to the end because it is doing word by word. Now, whereas because of self attention, transformers keep track of all the words at the same time, allowing them to have a better understanding of the context. This is why BERT is very good at understanding complex sentences. Maybe this is what ChatGPT might be using. I'm not sure. I'll go and Google about it later when the time comes. So, yes. And bidirectional understanding. The third reason is bidirectional understanding. It reads from beginning to end and again from end to beginning in from both direction. So sequential model like RNNs or LSTMs usually read the sentence from left to right or sometimes from right to left, but from one direction only. BERT, however, reads the sentence from both directions, left to right and right to left. This makes it much better at capturing the full context of a word based on the words around it. Makes sense. Makes sense. So I understand why transformers have a upper hand here. At least they look like at textual related words where we have to get the context or we have where we have to generate text, because it reads all the words at the, so it keeps a track of all the words at the same time. That is why it is faster. It does this from both the direction. That is why it is able to capture the full context easily and faster in comparison to sequential model. Now, an example would be to understand the word orange in two different sentences. I want to eat an orange. I want to eat an orange. And the second sentence is, the color of her dress is orange. Sequential models like RNNs or LSTMs might take longer to understand the meaning of orange because the process they process the word one by one. Correct. And transformers like BERT would immediately look at all the words eat and color and figure out the context from all the words at the same time, understanding that in the first case orange is a fruit and in the second case orange is a color. Makes sense because it is looking at all the words at the same time. So we have understood what transformer models are, transformer based models are, and what is this BERT, and how it is different from the sequential model. Now I feel I am confident enough to go and do what? Start coding. So what we have to do? We'll have to set up the BERT model for text classification. Okay. Use IMDb dataset for training and evaluate models performance. Cool. So we are going to use Transformers library from Hugging Face, which provides pre-trained BERT model that can be easily used for downstream tasks. Okay. So we will be using Transformer library from Hugging Face, which will provide us the BERT model that we can use it. So let's download it. Pip install transformer. Meanwhile it is installing the transformer, what we can do, we already have TensorFlow installed, we already have datasets installed. I don't think if datasets are installed, I don't know, but what we can do, install it anyways. Yes, it was not installed, so let's install it, and then we are going to import the libraries, but let's wait for it to get finished. Meanwhile what we can do, we can create a Python file for today's problem. It is going to be day27.py. Let's add it. Let's mention what the problem is about, and let's mention the problem is this. Now we'll do what? We'll start importing the libraries. Import transformer TensorFlow as TF from transformer. eh, Let me close it and then open it again. I'll say trans. Let me do what? Close it, open it again, and open this file, minimize it a little, and then say from transformer. Is it not installed or what? I'll install it again. So we have an error. We have encountered an error. So we have got an error. Let me clear this error and then come back. Hi, so I managed to fix the error. It took me a good amount of time. It took me more than 2 hours to fix the error. So the problem was with the compatibility of Transformer and the Python version. I did a lot of things from upgrading and installing Rust with different methods to upgrading and installing TensorFlow at specific versions. So what has worked with for me is to install TensorFlow and Transformer with these versions. And also what I did, I have upgraded my Python from 3.8 to 3.10, and that I guess has solved the error, solved the problem mostly. What I'm going to do now, I'm going to start with it. Let's start and uh, run the file to load the database. So load the data set and see what is in there in the data set. And now when I'm running it, it is going to take some time. So let's wait for a few seconds for it to generate the output. And this is how it is giving me the output. And these are the sample values, the text and labels. Number of rows are 2500. Then we have text and labels, number of rows 2500, and then text and labels we have number of rows at 2500. Now so I'm now not going to go and see what is in the data set, because I believe, let me go to the steps that we saw earlier. Yes, not here. I guess too much. Yes, not here, not here. Yes. So we just have to load the data. I believe that we have 50,000 reviews split equally into training and testing. And the reviews are into 1 and 0. 1 represents positive and 0 represents negative review. Let's load the BERT tokenizer. So let's minimize the terminal and load the BERT tokenizer. So I'm going to do what? Load the BERT. So I'm going to do tokenizer. So I'll load the BERT tokenizer dot from pre-trained. Let's mention the value here, the from which base, and then create a tokenizer function. What are we doing actually here is we are passing the text of the movie, so movie information, we are movie some information about the movie, and then we are convert tokenizing it, so tokenizing it. So we'll do what? Def tokenize function, and we pass the example cv movie. Let's say movie. Here return the tokenizer, pass the movie text, and padding up to max length, and the truncation, yes, truncate, and the max length is what are we going with? 128. And let's do what? Tokenize our dataset. Tokenize the dataset. So let's do what? Tokenized dataset. So it is going to be dataset dot map the values of this dataset, map to this tokenized function, and in a batch form. Batched, yes, true. Once we have got the dataset, tokenized dataset, we are going to prepare the dataset. Prepare the data set. So what are we doing here? We are converting the data set, tokenized data set, into TensorFlow friendly format. So we are converting the data set into TensorFlow for friendly format. So what are we doing? We'll first convert the TensorFlow dataset and prepare train dataset. So train dataset is going to be to- tokenized dataset. Here we get the train section, and we get the two term frequency, sorry, term frequency dataset. Here we mentioned, let's read a little about this function. Uh, let's read a little about this function. So yes, function to set the dataset format to be compatible with the TensorFlow. So we are making our dataset to be compatible with the TensorFlow. So we will need to import the data collator form. So what we have to, this function is used to convert to TensorFlow dataset. So not term frequency, it is TensorFlow dataset. Here we pass what all we need to convert. Here the label, batch size, collate, and everything. So let's go with what it says. So the columns are, let's let's have a lot of spaces so that the code remains in the center. So it is going to be input IDs and attention mask, then label columns. Label column is label, and shuffle, yes, batch size 16. Shuffle, yes, batch size 16. Then we'll prepare test data set, tokenized data set on the tests used to TensorFlow, not to pandas, to TensorFlow dataset. Here we mention the columns. Again the same thing, yes. But here we are shuffling. No, we are not shuffling because we want to train in the same order, right? So now we build the BERT model for classification. Build BERT model for classification. So what are we going to do? Model BERT transformers BERT for token classification. From pre-trained, let's mention the same. What are we getting? The pre-trained base, and then we mention a couple of things. Number of labels we want, number of okay, and then we are going to compile it. Model.compile optimizer Adam. So let's import the Adam first from TensorFlow Keras optimizers import Adam. So Adam, the learning rate is 0.002. Is okay, 0.0005, and the loss is sparse okay, sparse cross entropy. I guess that should also work. Sparse categorical cross entropy. We have been using it. Let me go and check it. So here we have used it. Not, let's check it in the D6. Binary sparse categorical cross entropy. So instead of imputing the class, what I'm going to do, I'm going to use this, and the matrix matrix is going to be accuracy. Done. We have compiled the model. Now we are going to train the model. So we'll do model.fit. Here we pass the train Train dataset, validation data is test dataset, and epochs, how many epochs? I guess 10 epochs, 3 epochs only. And then we are going to evaluate the model. Evaluate the performance. Evaluate the model, let's say. So loss and accuracy is going to be for model dot evaluate on X, not X, test dataset, and let's print the accuracy. Print the loss is loss, accuracy is accuracy. That's it. Let's run the model. Let's remove the unnecessary lines here first. Let's run this code and wait. Hopefully we should not get any error because we've already invested good amount of time in figuring out solving the error. We have at line number 25, 25, 25. Oh, here we pass it like this. Correct. It should not. It should work. It was a syntax error. So uh, it is mapping. So it is at this line. Mapping tokenizing, basically it is tokenizing each text with these configuration. So let me pause the video and then come back. Hi everyone, so I'm back. uh, so I am able to fix the error. So the change that I did was to change this uh, TF, TensorFlow BERT for token classification, to TensorFlow BERT for sequence classification. And here we did that while we were defining this, building the model. Once I did that, I was able to fix this error. Then I ran the script, and then for training one epoch it took around 2 hours. So then I decided to stop and not record, because 2 hours I cannot continuously record. And then once the all the epochs will be done, I was like, okay, then I'm going to print it, make the video. But here, if the epoch one epoch is taking 2 hours, then I'm deciding to stop it, and this is how I'm thinking. So the loss started with 0.69 and the accuracy is 50%, and might go to like 50 to 55 to 60% at max. So this is what we wanted at the end. This is what we wanted to print at the end. What we have learned from today's problem is that what is BERT, why we are using BERT, what are TensorFlow, tensor transformer models. And then we built a model, and we also learned that it is going to take a lot of time to train transformer based models. So let's do what? Let's commit it. Day 27, not day 27 dot py, and then commit day 27, build and train BERT model. Let's push it to main, and yes, let's it should be available on this public repository. And let's go and edit this, these recordings, and yes, let's come back tomorrow and do our 29 28 day problem. which is to fine tune the BERT model on a custom NLP task. And thank you very much.